Right, the first step is to get one of these flanges. It has an 8mm diameter hole in the middle, and using these little grub screws, there's 2 of them, do them up tightly. Once you're happy with the design, I would actually put thread lock on them, Loctite thread lock. You don't want this breaking free in use. This is 8mm rod. If you go to your local hardware store and buy it, you'll actually find it'll be about 8.5mm in diameter. You actually want precision metal rod. So if you Google, or your search term should be precision metal rod, and then it will actually be 8mm. Cost a little bit more, but then you don't need much of it. So you fix that on, and then your next problem is what this brake mechanism has, this disc brake in the middle, and you can see there's a thread all around here to screw onto the electric bike hub. Now of course we don't have that, so I've got to find a way of fixing this to this so it's not wonky, so it doesn't go around like this and it doesn't go around like this. It's got to be perfectly central. So I 3D printed this adapter, and it's a little bit hard with one hand, but basically I've also noticed drilled these extra 2 holes, which we'll come to in a minute. So you see how this lines up. This lines up, and then you just push it in, you see, and it ends up like that. Let's put the camera down. So we'll push that in hard, there. And then the next thing is there's 2 screws. Now with my printer, if I specify a 4mm hole in my design file, once it's printed on this printer, because the plastic extrudes a little bit out sideways, that's just slightly less than 4mm, which means if you take a 4mm bolt, you can screw it straight into it and it will actually cut its own thread. So I'm going to put one in there and one in there. Whoops, one in there. So these 2 cannot come apart. So I've done that. I like using these hex socket headed bolts. It's worth buying a set of these. They're screwdrivers with hex heads, and they're way easier to use than the cheap L-shaped ones designed for these, and you'll probably only ever buy one set in your whole life. So the next thing I'm going to do is bolt this. You see there's 4 holes here to this, and it's 3D printed to accept it. So put the camera down again, if you can see. So that now should be perfectly central. Now this isn't necessary to make the mechanism work, it's just for visual effect, but I'm going to put this over here, and using these 4 bolts into these 4 holes, it will hold the whole lot together. The other thing I've already done is fix this into this 3D printed structure. It could probably be made of stacked laser cuts, 6mm thick, but all I've done is I've taken the spring off this part here, so you can see how this works. See, it just pulls the band round, and this big hole here just allows the stamped raised part of the back plate to poke through. I've glued it in here with Evo stick, and I also put a little bolt there. That could possibly be made of wood though. Right, the next thing I've done is I've screwed bearing to this one and a bearing to this one, like that, one each side, and you'll notice that these panels are exactly, here's an upside down nerdy-gurdy, see, they will exactly fit somewhere in the end here. Obviously you might lose these two panels, but they will glue in, and also they're exactly the right height to glue in. Maybe I shouldn't have put holes in this one because that might be the back panel actually. Oh well, never mind. Okay, so that's ready to be assembled now. So we put this up like this, and then that will go through there, and the drum brake will go into place like that. So now we'll fit the front and the back panels. Just for now on the back I'm using these nuts as spacers, but obviously when it's redesigned we won't need those, it'll be all built into the design. So that's one side on. I should say the bearings here also have little grub screws in them, and they're currently backed off so the shaft can freely move between them. We'll adjust it all later. So now I'm going to put the panel on this side. So once again I'm just literally screwing 4mm bolts into holes in the plastic, and because it's been 3D printed this way with the filament going around like this, it goes in, it just expands it slightly and just grips. Now because the grub screws are loosened here and here, I can slide the drum and this will in and out a little bit, so I can actually just make sure nothing's rubbing. Hard to do with one hand, but you can see that looks pretty good. So then I'll tighten these up and these up, because we don't want any lateral movement with respect to this magnetic sensor. There we go, that's spinning freely. So the next thing is, this needs to project an exact amount, because we're going to put our cap on it that has the magnet glued into it. So with the current design of sensor housing, which could change admittedly, currently this distance needs to be 12mm, and then this will just push on, hopefully. Okay, like that. And then this fits over this assembly here. Okay, so that's on. I've actually stuck it on with a bit of wood glue so it doesn't tend to stick itself to the sensor. I'm using wood glue because on metal that's actually quite a weak glue, which is kind of what I want, so I can pull this off if I need to. So the next problem is this. If you look at the square thing down there, that's the sensor. You'll notice it's not in the center of the board, it's offset slightly to the left, so you want this to be directly above it. So you have to bear that in mind when mounting this, that it's slightly off to the left. So if you just bear that in mind, okay, that's why there's a hole in the side, so you can so it gives you a window, you can see where this is relative to the little black sensor, and you try and get it as central as possible. It doesn't have to be perfectly central actually, to within fractions of a millimeter, but it does have to be more or less central. So there you are. So that's screwed on with great care. I'm using an Arduino Uno at the moment for testing, but I may change that to a Teensy LC. The reason is the Teensy LC has a proper genuine analog voltage output port on it. It's not a series of pulses, it's literally a proper analog output, which means it would make this a direct swap for the crank motor system, which also of course puts out a voltage which is read by the main computer on the main board of the DigiGurdy. So it just keeps everything a bit retro compatible when it comes to the software if I do it that way. And the Teensy LC is low power and it's fairly low cost. So you can see that's rotating nicely now. The little magnet is held just in the right spot, just a little bit away from the sensor, but not far. See that going round. And the other thing I need to do now is I'm going to experiment with a tuning peg here. As you turn the tuning peg, it will pull this with a little piece of nylon out, and so adjusting the tension. So there you are. It reminds me actually of the old wind-up clockwork motors, the really old ones that used to be available with Meccano sets. It somehow just has that look to it. Right, this is version 3 of the crank system. The width of this is such that it will exactly fit just inside the sound box of Nerdy Gurdy, or the Digigurdy variant, and this height is the same. This part above this line would be visible. Okay, so it gives you the right visual effect. And what I've got here is I'm just testing a tensioning system, which is simply a bit of nylon attached to the lever connected to a tuning peg. Turn the peg, pulls it a little bit, and the drum brake is engaged. It's just mildly, lightly on at the moment. Something else I've realised, I've had to reprint this part several times. The magnet has to be located bang over the centre of the sensor, which is actually not in the middle of this board, to make it awkward. So what I've done is I've got extra large holes here and here with wide washers relatively, so you can move this grey part left, right, up, down, a couple of millimetres each direction, which helps get it right. And then I'm also not screwing this on. I've held it on with blue tack until I get the readings correctly, and then I'll put a tiny daub of glue gun glue here and here and remove the blue tack. And the other thing is the magnet has to be extremely close. Probably seems to be less than 1 millimetre away. I don't know if you can see through there, probably not. The actual sensor. So I actually had it touching the sensor, and then I just moved it in a fraction. And what we find now, if I turn the handle, if I engage the app, right, it's running. You do one loop to calibrate. Now on the left is the angle. You can see it gradually goes down to 0 and then back to 360. Here we go, 360. And then this value is the angle difference between one reading, the previous reading, and the current reading. So as you crank, the faster you crank, the larger it gets. So if I crank at a kind of average speed, it's reading about 15 to 20. And if I accelerate above 35, you get a buzz. So I think that will work conceptually. I think that will work. So the next thing is to lock this down with 2 drops of glue, and then I'm also going to try converting the Uno here, Arduino Uno, to a Teensy LC board. I've now got a Teensy LC attached to this, and if I crank the handle you can see it's working exactly the same. Angle goes down to 0, then 360. And the right hand one is the speed, and crank it, get some buzz. The advantage of the LC, as I've said before, is it's got a genuine analog voltage output pin, which means I can connect that to the analog input of the main Teensy on the main board, and it will work just as the gear motor system does, with the little adjustment knob, which makes that a direct plug-in replacement with a little bit of wiring. So that's good.